Welcome to Science, everybody. Let's go through these seasons questions, see how you did. Really do try them first. Don't just watch this video if you haven't tried them yet. It's how we're going to get better. There's a couple of challenging ones at the bottom. We'll see how they went. The diagram below represents the Earth and space on the first day of a season. Which season is beginning in New York State on this day? That's going to be... what are we going to write with? Orange today. That's going to be, we're at like this latitude right there. You do have to recognize about where we live. It's right about up here. Or just the idea that the North Pole is leaning back away from the sun's rays. Both of those. And this one's going to be that we're like mostly dark with a little bit of light and the sun's at a low angle. All of those signs all pointing to winter. Let's switch to red. Red feels more contrast, a little easier to see. Okay, come up here, number 6. During which northern hemisphere season is Earth closest to the sun? So this is working on that A, elliptical orbits thing, and B, that idea that it's not a reason for seasons because we are actually closest in winter. Didn't give me red. Let's try that again. 7, seasonal changes on Earth are primarily caused by the... Why do we have seasons? Parallelism of the sun's axis as the sun revolves around the Earth does not sound anything right. Changes in distance. So there's that idea again. We know that happens. This happens, but it's not why we have seasons. Elliptical shape of the orbit is basically 2 and 3 almost say the same thing. And there we go. 4. Tilt and revolution. All right, let's... I want to go down. There we go. 34, the diagram below shows Earth's orbit around the sun. A, B, C, and D represent the Earth on the first day of each season. Which one represents March 21st? So a couple of parts to this one. You'd have to recognize that March 21st is an equinox. Second, you'd have to know which positions, multiple or equinoxes, which are going to be C and A. So how do you get out of it? How do we know which one of those two it is? And if it's March, that's spring. That's after winter, right? So you'd really have to recognize which one is winter and then say which one's after that. And over here with the North Pole totally in the dark, leaning back away from the sun, that's going to be winter. 3 months later at the equinox, we should be at March 21st. So we're going A. If you guess C, you did pick an equinox. That's good, but you picked the fall equinox. D being winter and B being summer. Hopefully we didn't go for those. State one factor other than the tilt of the Earth's axis that causes seasonal changes. It's just straight up. You could answer this with one word. Revolution. Probably better to say like revolution of, not or. That should do it. All right, challenge question. This one's a little bit harder, and then we get to some definitely harder ones down towards the bottom. If the tilt of the Earth's axis were increased from 23.5 to 30, summers in New York would become what? Let's steal from one of these diagrams. In fact, I'll come down here and steal from this diagram. Here's a 23.5 degree tilt into the sun's rays. So this right here is summer, which maybe gives away some of these questions down here. I don't know. We'll see. But what if that angle right there that you're looking at, I'm going the wrong way, the camera's reversed. What if that angle were even more into the sun? I mean, we have summer here because the rays are hitting us more directly because we're spending more time on the light side of the planets as we do one rotation around the axis. So what if that angle were even more? What do you think? Also think about this. If the reason for the seasons is the tilt, let's ask the opposite of this question. What if we had no tilt? If we had no tilt and you took this axis and you made it straight up and down and it went around the sun, we'd always have the same exposure. It'd be like an equinox every day. So the seasons would kind of go away. We'd just kind of adapt to one length of daylight, close to 12 hours, kind of like what we have in spring and fall. Only in climate, some of those things are affected. Like temperature-wise, the climate would get a little bit weird, but it'd be more consistent anyway, right? So this question is asking, well, what if the tilt was even more? Well, if we have summer because we're tilted towards the sun, if we're tilted even more towards the sun, what's going to happen is, there's a variety of things. Temps would be hotter, days would be longer, sun would be higher in the sky. I'd say the first one is the easy one. The hard question, but of those answers, that'd be the easiest one to go for. Just it's going to be warmer. It's warm in summer because we're leaning towards the sun. So if we lean more towards the sun, it's going to be even warmer. Sound good? Which factor is a primary cause of seasonal changes on Earth? So change in distance, there's that again. This is kind of like the one up there above. Change in rate of Earth's rotation, that does not change. That stays pretty consistent. We would feel accelerations and decelerations if that were changing. Wobble of Earth's axis does happen, but happens over a very slow amounts of time. Like, you got to go back to the pyramids to when they were building those things for when we were pointing at a different North Star. And there we go. Surprise, surprise, if we're not getting repetitive here. Tilt reverse axis. All right, cranking up the difficulty a little bit with these guys, especially the last one. Identify the season that is just beginning in the northern hemisphere when the Earth is in this position. So we covered this. Now, I really like this question, even though the set of questions, even though they get hard, because they're going to let us see. We'll have to talk about this in a number of ways. If you're near the equator, basically you've got 12 hours of daylight, which we'll do in red, and 12 hours of darkness. You're half and half. You're half in the sun and half out of the sun. Now, as you go towards whatever pole is leaning into the sun, which in this season, this is summer, you can see that the daylight for us, we live in the mid 40s. So maybe right about there. We've got all that daylight as the planet spins through this thing. It takes 24 hours, one day for it to spin. It spends most of its time, our latitude, Alaska, New York, or just Lake Ontario in general, spends most of its time on the light side of the Earth and then less time on the dark side of the Earth. That's the summer solstice. That's June 21st. That's why it's light for so long. The sun hits this higher angle. That's why it's warm. And then the exact opposite down here in the southern hemisphere, right? I was trying to find a city on our latitude down here. There is one in South America, but there's also Christchurch, New Zealand. Now they're on the other side of the Earth. They're at a far different longitude, but all we really care about for seasons is latitude, because they're going to do basically the opposite. They're going to have this little tiny short line on this day. So this is kind of like what we have on December 21st, right before Christmas. Is, oh man, we got to do all of this spinning through the dark side of the Earth and only a little bit over here through the light side of the Earth. So a lot of babbling for what I think this first one is a pretty easy question. Summer. State the number of hours of daylight that would experience at the equator 3 months after the date represented by this diagram. Now, I think they try to complicate that question a little bit more than they needed to. I don't care if it's 3 months, 4 months, 5 months, 6 months, whatever. Since the equator sits right here, as that pole does this, which, again, remember, it's not really that, it's not going back and forth. It's staying the same, but it's going around the sun. So if my face is the sun, it's like this one time and then whoop, like this another time. So the tilt doesn't change, but on these diagrams, it feels like it changes. But it doesn't matter, no matter what. Since the equator is like halfway, wherever you have that axis tilted, it's going to be half in the sun and half in the dark every day, all year round. So seasons for them, if you want your seasons unit to be easier, move to the equator. 12 hours of daylight, 12 hours of darkness on this day, the next day, and everyone after that. All right, last one. State the general relationship. Now, if you were tuned in on those other labs where I was talking about relationship questions, remember we always go, if you're going to do the relationship between one thing and another thing here in neuroscience, we're going to do them all year round. And I always give you the same example. I'm sorry if it gets repetitive, but I think it helps. If you state the relationship between hours worked and money earned in an hourly job, you would say, as I work more hours, or as hours worked increases, money earned increases. So how does that first variable affect that second variable? So down here, let's like just always use that format. It's the easiest way to do it. As latitude, that's the first thing that they're asking for. And then you can choose either increases or decreases. I think it's usually. As latitude increases, now the rest of the question gets a little bit complicated. The duration, sometimes people don't know what that means. Duration is the amount of time something takes. The duration of a period at Alaska is like, what are they, 41 minutes? Something like that. The duration of a football game is 15-minute quarters, right? 4 15-minute quarters. It's how long something takes. So the duration or amount of time that the sun is in the sky, basically, insolation, incoming solar radiation, sunlight, on this day. So what it's basically asking, and I think it's kind of a wordy question, and that's difficult. It makes you think a little bit. What it's basically asking is, as you go from the equator and head north up towards 60, what's going on with that duration or that amount of sun, the amount of time that the sun's in the sky? Well, look what's happening to like that red line at the equator versus the red line that I drew for us. It's getting longer and longer and longer. So here in the summer, as we do that, as latitude increases, the duration of insolation, just always steal right from the question. Even if Google Docs doesn't think it's a word. As latitude increases, the duration of insolation increases. So as you go further north, the days get longer and longer and longer. If you were to ask it the opposite, as you go further south, the days are going to get shorter and shorter and shorter, and balancing out at about 12 there. And then again in 3 months, the axis will be straight up and down on this paper, which would mean like leaning in or leaning out, but everybody would be at about 12 and 12. All right. What do you think? Feeling good? We'll figure out what we'll do for some kind of classwork quiz test, something soon. Take care, folks.